Hi there, everyone, and welcome to this afternoon's webinar on applied machine learning. We're glad to have you join us this afternoon. My name is Bertram Haskins, and I am the line manager for applied machine learning. That's quite a mouthful, so you'll hear many times throughout the presentation. I might just refer to it as AML, which is a little bit shorter and rolls off the tongue more easily. You'll see in the presentation with me today, I have Leon Grobelaar, who is a teacher on the AML program. So if you do decide to join us, you will get to know both of us quite a lot better over the course of the year or two that you're with us. So if you'll allow me, I'm going to add a little bit of screen sharing. So what are we going to talk about today? Well, we'll be having a general discussion about what is applied machine learning. After that, we'll continue our discussion by talking a little bit about the program structure, i.e., what is it that you can expect to do in the courses in the applied machine learning program. We will then continue and talk about the thing that many people are interested most. What are you going to do as a student in the program? We'll follow that up with a little brief discussion on what the job market is, i.e., what do you do after you've studied? And then lastly, what do you need to do to qualify to study AML? So the first step in our discussion is, what is this thing? What is applied machine learning? Now, in today's world, all of us know, or I've heard probably at this stage, about a little thing called ChatGPT. Now, at this stage, with the world being abuzz with AI and machine learning, I don't think we can have this discussion at all without at least including the voice of ChatGPT. So to that end, let's ask ChatGPT's opinion on what it thinks machine learning is. Isn't that fantastic these days? You can have an online chat platform that you can basically ask anything, including code, etc., and it will come back with an answer. In this case, it's telling us a little bit more about its own field. So it says that machine learning is a subset of artificial intelligence that involves developing algorithms and statistical models that enable computers to learn from data and improve their performance at a specific task over time without being explicitly programmed. That's very apt and it's very accurate. So applied machine learning, or machine learning specifically, is a subset of artificial intelligence. And very interestingly, this field has really blown up in the last few months, specifically because of tools such as ChatGPT, Midjourney, etc. I don't know how many of you have been following this, but you might have noted that GPT-4, which is the language model on which ChatGPT is loosely based, it's based on a subset of it, was actually released last night. And for those of you who are already in the plus version of ChatGPT, you can now start playing around with it. There's a few very interesting things on the horizon that even deal with visual aspects, in that we will be able to feed it images and it will be able to tell us what's on the image and actually take a drawn image and start developing code from that image. So you have chosen to attend a webinar of something that is very much a growing and a booming and an interesting field that is going to permeate into every single facet of most people's lives in the foreseeable future. Now, plainly put, machine learning is really taking a variety of different computing algorithms with the goal of kind of imitating the way that humans learn. Whereas AI is sort of an overarching term that tries to imitate basically what a human does in various forms and facets, how we think, etc. The subset of machine learning is more geared towards how we can train a model using data. Now, we do this by the creation of statistical models for the purposes of, firstly, classification, which means to identify where something fits. So taking a look at an image and saying, oh, this is a cat or this is a dog. Or say, for instance, for prediction, also called regression. So in other words, trying to make predictions regarding the future. So taking things like historic sales data and predicting what could happen in future. Now, I know a lot of people's eyes gloss over when you read stats or maths, but that's where the applied bit comes in. This isn't traditional computer science or IT or anything where you have to worry about that you need to construct these kind of models from scratch. So you don't need to be the person who knows the absolute mathematics behind being able to statistically create any of these machine learning models. But what you do need to do is, and what we do from scratch in this program, is you need to learn to program. And you will do that quite a lot because you're going to program in several of the courses in this program, as you'll hear in a few minutes. Now, the idea is that in the modern day landscape, in programming, especially in machine learning, there are so many off-the-shelf, ready-to-use libraries that you can use to aid you in the creation of these machine learning models. So it's applied in the sense that you apply existing tools to do it, but it's also applied in the sense that machine learning and AI in general never functions as an island. We basically apply it to a variety of domains. So whether you are in health, whether you are in finance, whether you are in education, as ChatGPT has proven to us, you can apply machine learning in a cross-disciplinary fashion to almost every walk of everyday life. So the program itself, how is it structured? It covers 38 academic weeks. Now, if you're a part-time student, you need to sort of multiply that by 2 because every academic week becomes 2 calendar weeks, which means if you're part-time, you take double the time that a full-time student would complete it. Now, over the course of the program, we will cover 7 courses, namely problem-based learning, introduction to programming, introduction to data mining, data pre-processing, programming for machine learning, computational intelligence, and data visualization. Now, don't worry, we're going to revisit all of these in a few seconds. And after you've completed all of these courses, you will take the sum total of the knowledge that you have accumulated, and we will complete an exam project. I say we because we do it community driven. The idea is that you need to chat to your teachers, be online, communicate with us. I like to refer to the exam project as the experimental project because this is when you get the chance to experiment in a safe environment over a few weeks to prove and test what you've learned throughout the program. So our first course, problem-based learning. Now, before you can perform any kind of analysis, you need to be able to define a problem. Now, defining a problem means you firstly need to be able to break it up into smaller chunks and then take those chunks or segments and create a plan for yourself. And that holds true for any project. And that is why we start applied machine learning with a little bit of problem-based learning. We continue in that by showing you the fundamentals of how do you write a report? In other words, how do you tell others things in written form? And then we show you of presentation. So your first course isn't strictly machine learning, but it gears you towards starting to work in that space because it teaches you how to decompose a problem and scope it as a project. Secondly, we start with a course called Introduction to Programming. And if I say introduction, I really mean it. The idea is that you should be able to walk into AML with absolutely no prior programming knowledge. So we teach you everything from the fundamentals in a language called Python, which is really widely used in the machine learning and data science spaces these days. And we also teach you the basics of software design. We teach you control structures, in other words, to control how logic flows throughout your program. We go further, we do a few extra libraries, very basic things still, and we explore things such as file systems, and also we consume services, i.e. we make use of application programming interfaces, or APIs. So in other words, we teach you how to consume information from the web, which is also something that you need to be able to do when you're working in the data space. Our next course is Introduction to Data Mining. Now, you can imagine the first two courses as sort of laying the groundwork. So firstly, teaching you how to decompose a problem, then teaching you programming, not specifically for machine learning, but programming in general, so that from there onwards, we can start applying it throughout the course. Now, from here on outwards, all of the courses sort of follow the pipeline that you need if you want to work on a machine learning based problem. So the first of these, Introduction to Data Mining, teaches you about the fundamentals of data mining. How do you put data together if you have different data sources? What is the meaning of the data cube? It also teaches you about how to discover patterns in your data. It shows you what you can consider to be interesting. Because remember, in the field of machine learning, it's sometimes called an aspect of data science for a reason. Because in machine learning, the way that we curate our data is what basically contributes to what our outputs would be, what our model will look like at the end of all of this. So our first fundamental step to get the data in place, to combine all of our data sources into a data warehouse, is our first most fundamental step. And if you get that wrong, obviously throughout the entire rest of the process, you sit with data that might not be prescribing the problem that you're actually trying to solve. Next up, we have data pre-processing. Now, generally, when we get data, it's not very neat, especially if you get data from a variety of sources. A silly example, if you get data from two data sets, from two different vendors, one comes from one portion of the world, another from another portion of the world. They might be representing something as simple as a date differently. But we want to consolidate those sources so that you have a single way in which the data is presented. So in this course, we basically go and take a look at what we can do to pre-process data before it is fed into our machine learning models. So we standardize the data, we do a little bit of feature engineering, and we figure out whether, if there are any quality issues in the data, how we can address or resolve it. And most of this uses fairly fundamental concepts and fairly fundamental programming concepts. So you'll see in this course, you already start touching on programming again. So beyond introduction to programming, this is your second subject in which you will do programming. Then we also have programming for machine learning. Now, as you guess from the title, this is definitely a programming course. In this course, we start taking a look into more in-depth machine learning libraries, not specifically machine learning libraries, sorry, data processing libraries, ways in which we can store data differently, different data structures, etc. And we learn how to programmatically extract features. So what do I mean with that? A feature is something that we use to describe an aspect that will go into a model. So a simple way to think about a feature is if you have a spreadsheet, every column in that spreadsheet could be a feature and every row could be a data point. Now, say for instance, we have an image. You can perform feature extraction on the image to extract several data points that describe the cat or the puppy or the kitten or the kite that you are looking for in an image before we get to the actual machine learning part. So once we have all of that in place, we get to a subject called computational intelligence. Now, computational intelligence is where we take the pipeline to the next level. We start going and we take the data that we have pre-processed in its current state, and we start creating models for it. Now, those models, as we've said, are based on predefined tool sets and libraries. So our main goal is to decide beforehand what are the interesting features in our data. We pre-process them and then we feed them into other models that we'll create. Now, the models focus on classification and regression problems or prediction problems. We could do clustering, where we feed a data to try and determine groupings within our data set. We can also do genetic algorithms, which is one of my favorites, where we basically evolve towards an optimized solution. Now, the little video that you see on your screen, that is an example of a genetic algorithm in action. We basically have something called the traveling salesman problem. So you have a salesman that needs to travel the countryside, and the idea is that the salesman wants to do this as efficiently as possible. He or she needs to visit every single city, but only once. So the genetic algorithm helps us figure out how to get to the most optimal route. And then obviously any discussion in machine learning these days cannot not include an overview of artificial neural networks. This is what most people typically see as AI, because it's probably the thing that maps the closest to a biological brain. Followed by that, lastly, we have data visualization, which is a course that teaches you, again, programmatically, how to visualize your data. In other words, how to take the data that you've created, visualize it, or even to take the machine learning instructions, such as the network that you've built for your neural net, and to visualize that. As you can see, about 4 or 5 of the courses that you're going through all reinforced your fundamental Python skills. At the end of all of this, we have an exam project. The exam project, you can scope your own one, or you can chat to your teachers to help you get one. Basically, anything goes as long as you are able to demonstrate that you can follow the pipeline throughout the courses. Interesting things, so say for instance, you can even do more game-related projects, such as trying to figure out what's the best way to get a character to move through a maze the most efficiently. So any project you can think of, you can go ahead and do. Then the day in the life of the student, what do you do on a day-to-day basis? AML is taught asynchronously, which means on a general day-to-day basis, you won't get a lecture from one of the teachers like the presentation I'm doing now. It will basically consist of you reading through content and watching a few videos. You can also complete some quizzes or do a few practical exercises and activities. Otherwise, you can also chat to your fellow students or to your teachers. Your teachers are available every workday throughout the entire day on Teams. So it basically means it's like sitting in a real world lab and always having your teacher available if you need to ask a question. Now, other than that, your life as a teacher will also include completing module assessments, i.e. assessments at the end of every week in the form of a quiz mostly, and which occur at the end of every course. Now, as for the job market, which everyone is always interested in about, Generally, if you finish a course such as this, you would be able to start at, and this is a different term to pin down. I recently had a discussion where I saw that for general computer science and IT related jobs, which machine learning forms part of, or data science forms part of, there's about, it's in the 9,000 different descriptors for very similar jobs. So in this case, we went with junior machine learning engineer, but you also might see it as junior data scientist, junior machine learning scientist. You might see it in some cases, even as a data analyst. Sometimes there's a little bit of overview because someone who does machine learning is assumed that you learned about data and how to find interesting patterns. So you'll see there's actually quite a lot of overlap. With all of your fundamental Python skills and the SQL that you learn in data warehousing, you might also qualify to be a junior software developer. Other people prefer to take a course such as this to augment their existing skills. So say, for instance, if you've already studied in finance, in biology, in anything else, you can use a course such as this to augment what you're doing, to help you get to that next level. And then lastly, as with any other computer science and IT related field, consultation, i.e. going out and doing things for yourself, speaking to people, getting work in and helping them is always an option. But as with anything, generally you first want to build up the experience. So the first two options is generally where you would start your career-wise journey. Now, lastly, our admission requirements. There's nothing specific except for a passion to be on the forefront of machine learning technology, which everyone is excited about these days. The general criteria, admission criteria, is similar to any other vocational program, i.e. you need to have upper secondary education. You can have Norwegian vocational upper secondary education, or you could possibly get in via prior learning or work experience. And that is it for my presentation. Thank you so much for joining us and for being interested in making this part of your journey in the fantastic world of machine learning and AI. I'll now open up the floor for any questions, if there are any. I'll stop sharing my screen so I can properly see you. As with any of the courses, what the teachers usually do, and I've had a bit of experience with it just in the past 2 weeks, we would serve as an advisory role. So seeing as though we've been sort of through the process, we know what's out there, we will aid you and guide you if you have any questions, and we can try and support you and say, listen, this is the process to follow. If this is what the company is doing, this is the kind of thing that you should think up about reading a little bit more in. Because as you'll see, many of these things are kind of, if you work in machine learning, you work in a variety of domains. So it always helps if you read a little bit more about the specific domains as well. Are there any requirements for prior knowledge? No, not at all. We basically take you in as a blank slate. We assume that when you come in to study with us, you want to learn everything from scratch. So we don't assume any prior knowledge beyond possibly being able to turn on either Windows-based or Mac-based or Linux-based machine. But beyond that, there are no prior requirements. Okay, so cool. That was it with regards to questions. Thank you so much for joining us. I hope you enjoyed the presentation, and we hope to see you soon. Enjoy the rest of your afternoon and any other presentations that you're going to sit in on. Bye, everyone.